Okay, let me open. Okay, so this is what UI. Tell me, this is what UI. UI is what?
Snowflake.
Snowsite UI. Snowsite. See how many ways I can able to log into application Snowsite. We can go for Snowsite
CL,
UI,
CLI.
Classic Console. One more thing. Snow SQL CLI. We'll see the same thing. As of now, we're working on Snowsite user interface. Okay, let me open one more session. Now what happened now? I want to create one simple table. See, so create table. So EMPT. Okay, ID, number, name, varchar. Okay, city, varchar. Okay, now what happened now? I want to have the business rules. Tell me how to enforce business rules based on which concept? Which concept?
Constraints.
Using constraints. Constraints. See, so with the help of constraints, we can go for the concept. Suppose like see, I want to go for a not null constraint, or else I go for a unique constraint. Okay, I should go for here. I'll go for
Not null.
what? Not null. Okay, for understanding purpose. Okay, so this is my thing. How to create? Okay, see. Okay, so this is the functionality. Okay, so this is so. Wait 1 second for me. So what? Tell me if I want to create any database object, what I require?
First, database and schema.
Okay, so database and scheme. 1 second. Okay, see. Now what happen if I want to create, if I want to do anything, what I require, okay, database and the schema. So how many ways we can able to use set worksheet context, or we can able to drop down like this. Okay, or else we go for what command? What's the command? Use database and the database name. Suppose I want to go for this AF database. Okay, see, use database name. Same thing, use
Use schema.
schema name. So dev sc. So this is my schema. Okay, tell me by using query, I want to find what's my database name. Select not show
Current schema.
current database and current
Current schema.
current schema. So current schema. So same thing. In this database, in this schema, I want to find list of tables. Tell me how to find list of tables.
Show tables.
Show tables. Okay, show tables. Starting with T. How to get starting with T? We should go for T
Like
percentage.
T
Okay, suppose let's
percentage.
see, I want to get only these two. So T1, T2. How to get only? You can put simply can put two underscores. It will work. It will work as it is. Not a why. It's not a public scheme. So see, we'll get the three tables. So this is fine. Now what happened? I want to create one table. See, this is my table, important EMP table. Now what happened? Now I want to insert some records. So insert into EMPT values. Okay, so one. So Praveen, one more topic, just understanding purpose. So Hyderabad, Snowflake support multi-insert. We can insert few more records at a time. Okay, copy the same thing. Control C. This is called as multi-inserts to Kumar, Chennai. Okay, so this is my table. As you know, two records are there. Okay, now what happened? How to fetch the database? Select a statement. Select a star from table. Okay, so select a star from our table. So what's our table name? EMP. Now see, as of now, what? Okay, so two records are there. Okay, now what we are trying to discuss is that no, so by using by using Snowflake, how many ways I can able take a backup. So this is my table. Let me take the screenshot. Okay, see. So now we're discussing how can I take a backup in Snowflake. So this is my table. Now tell me now how to take a backup. Anyone tell me? Using CTAS. Okay, see CTAS. What is CTAS? Okay, now we're discussing by using Snowflake, how many ways we can able to take a backup. This is my original table. Now, how first way is that what? One is CTAS concept. What is CTAS concept? So create
Create table
table.
as select.
So see table.
As
So table name as
Select.
select star from old table. Okay. Old. Okay. Now what happened? Let me go here. So create table EMPT CTES understanding purpose as important, very important topic. Select star from our old table. Okay, see now what happened. Now see, first we should see the data. Okay, tell me how many records are there in my main table? There are two records. Okay, so what about the CTES? We'll get how many records? We'll also get two records. We'll get. Okay, two no, so two records will get. Okay, now how to see the definition of the table? Definition of the table.
condition where
See,
No,
DESC.
definition.
DESC.
No, this is the describe will give only columns, but I want to get the definition. So we go for get DDL. So basics don't forget. So get DDL. So table, and we need to pass the table name. See what happened? First copy the same thing. So see, we can able to copy. Let me open function. So change the language to SQL. Okay, come here. Now what happened? Copy our EMP table. EMP table. See, you can able to understand this is one important thing. Let me go back here. Control V, change the language to SQL. Now see in Notepad++, see what happened. So we can able to compare two worksheet. Tell me what's difference between two worksheet. This is main table. This is CTES table. And tell me what is the difference? What is the difference?
instance
So see, name is different. Apart from name, what any other thing?
Constraints.
So constraints are
Not null constraints.
Not null.
okay. See now here you need to understand here what happened. EMPT CTES. Okay. Now what happened here? Not null constraints are there. Unique constraints. Tell me constraints are getting popular. So no. So what's the conclusion? With the help of CTES, okay, we'll get definition. Okay. What about data? Data is getting populated. What about constraints? No constraints. Okay, see this is important. With the help of CTES now, I can create the table with the definition, with the data plus no constraint. Okay. Apart from CTES, is there any way to create a backup table? Any idea, anyone? Anyone apart from CTES, you're having one more concept that is like concept. So one more like is there. See, syntax create table name like old table. So this is the same thing. Okay, see create table name. Okay, now what happened? Go to like the syntax, same thing. So create table. So table name. So this is my main table. Control C, Control V. Like. Okay, what is the table? Like is the keyword. What's our table name? So EMPT is the table name. So Control V, Control Enter. This is so forward. Now see the data. Now this is important. Tell me what happened. Data is there. So data is not populated. Okay. What about definition? See, copy the same thing. Copy. Go to our the same functionality. So Control V. So see compare. Now tell me what is difference. What difference between two things? Tell me. Tell me this is main
We are
table. This is out.
we are getting constraint.
Okay, see only name is difference, remaining we'll getting the same thing. So see what is the conclusion we can say with the help of like. Okay, like we'll get definition, data is populating, no
No
data,
data.
no data. What about constraints?
With
Constraints are
constraint.
getting populated. This is so far. Okay, same thing. One more important thing that is what that is clone concept, important thing. Okay, see now with the help of CTES, with the help of like I have created one more important that is clone concept. Same syntax. What is syntax? Syntaxes are removed. So while giving intros now, syntax are important for everything. So create table. So table name, we should use clone is the keyword, old table. Okay, so the same thing. Okay, let me go back here. Okay, see what is syntax? Only put instead of okay, can you any name clone? What is the keyword? Instead of like put clone keyword.
Clone.
See clone. Now take the table name. See now what happens. See data populating. So data is populating. So let me see the definition. Okay, one important thing. Let me go back here. Okay, go here and compare. So this is now see what happened. Let me compare. What difference? Only name is getting difference. Okay, so constantly getting problem. So what's the conclusion? Tell me. So with the help of clone,
Definition.
okay, so
Yes.
definition plus data
Data
plus constants
plus
are getting
constraint.
populated. Okay, now this is so far good. Okay, this is normal thing. Okay, now one more important thing is to know what happened. Suppose see EMP table is there. EMP table contains two records. Tell me two records nothing but what we should require storage or not?
Yes.
Yes.
Yes,
Yes.
okay. See now storage. Now what about here storage is there? Here storage will be there. I'll explain it. What about here like storage will be there or not?
No storage.
No,
No.
because no data, no storage will be there. Okay. So what about clone? So here
Storage.
one, so no storage. I'll explain this thing. So this is one important thing. Okay, see. So before that, if you want to understand this concept, now you should have knowledge on Snowflake architecture. This is important. I'll tell in detail. Okay, see. So now we'll discuss. So if you want to understand this no storage, we should discuss this Snowflake architecture. Okay. Tell me how many layers are there in Snowflake architecture? Anybody knows, sir? How many layers are there totally?
3 layers.
Three
Three
layers.
layers. Okay, so three layers. Okay, see. Let me help you in detail. 1 second. So this is important, listen. Okay, see, there are three layers are there. Okay, cloud service layer, computation layer, and the storage layer. Okay, see. So now we're discussing what Snowflake architecture. Okay, see. So see what now? Cloud, computation, and the storage layer. Okay, let me help you the same thing. Let me copy everything and post here. Okay, see now what happened. Let me go back. See now, see this is Arjuna, this is compute WH. Now I am make it to suspend status, suspend status. Okay. Now let me create one table. So create table. So T67 ID number. Now this is what statement? This is create statement. That is DDL. Now what happened here? Tell me. Still this is in which status? Still in suspended status. Okay, but when I perform insert, now insert is a DML insert into T67 values. Now what happened? Tell me now. See what happened? Tell me. Now status to what? Green color. Huh? So see one more time.
No.
Understand this concept. Okay. So I'll explain background what happened. See suspend. Now let me create one more table. So still it is in which status? In suspended status.
Suspend.
Suspended status. But when I perform any insert statement, what happens? See, it is getting resume. Why? Anybody knows, sir? Why? Why? Tell me, Noah.
The database values are that.
Come again. Go ahead.
It's using
Is it because DML requires computation
No,
resource?
get correct only. Okay, see now what happened. So this is the computation power, nothing but virtual warehouse. So this is sitting in where? In this second layer. Okay, let me take the screenshot. Okay, we'll see this one. This is important. So see, there are three layers are there. Okay, so cloud service layer, compute service layer, and the cloud storage layer. Okay, now so the computation power. Now this is coming from here. Now let me go back here. Let me suspend the warehouse, and we'll see one more time. Okay, now, so let me create one more table. Now this is DDL statement. Whenever I create now what happen, which layer come into picture? The cloud service layer will come into picture. Okay, so this guy what now it contains access control. Nothing but what? So see, first layer is what? So cloud service layer. Okay, so what it contains, okay, the access control. Nothing but what? Access control, nothing but what? Okay, the authentication and authorization. Okay, see, authorization. Okay, nothing but what? Okay, see, whenever I log into any application, Snowflake application, this will be access with the help of access control. Now what happened? Now I create one table. So this table information is holding like it contains single column as of now, which data type, how many number of record is all the information will be stored by which guy is metadata. So data about data. Whenever I create anything now, what happened? Which layer come in picture? The cloud service layer, the metadata management. So this require doesn't any computation power. See one more time. I am creating one table. So this table information who is holding which guy? The metadata layer, the metadata management. So when you go here now, what happened? It doesn't require any computation power or any processing. Clear this one? So see, I'm trying to create one table, nothing but what this information is stored by cloud service layer, the metadata management. Okay, see meta. Now as of now, see, it is not require any no computation power, no computation power. Okay, this is fine. Now what happened now? Let me insert. Good.
What does it mean by no computation power?
I'll explain. I'll explain. See now what happened. Now I'm trying to insert one record. Inserting nothing but what? Tell me where our data will be physically stored, in which layer? In which layer?
Middle
In the
layer.
not
Cloud
middle layer.
storage.
Storage, not
Storage.
storage. Storage. Okay, see storage. Our data will be stored where? Physically in the cloud storage layer. Okay. But what happened? Who will place this data here? Which require what? We require CPU, RAM, memory. This will be given by which guy? The virtual, nothing but it's a cluster of machines. One more time. So see now our data is where our data is. So I'm trying to insert one record. Nothing but what our data need to be stored physically in this here. Now who will place this data here? Tell me who will place this data here? We require computation power. So computation power nothing but what tell me now computation power nothing but so if I want to process any DMLs, you see, if I want to process any DMLs or any DRLs or any data loading, okay, we require processing power. So processing power nothing but what's a computation power. Computation power is nothing but it's a cluster of machines called as virtual warehouse. Okay, see virtual warehouse. Okay, see, let me go here one more time. Now I want to insert our data physically here. But if I want to insert what I should require is this guy. Which guy? See, let me that's why what when right now it's in which status? If I make it to suspend, okay. Now let me insert one more record. Now what happened? Tell me. See, it require computation power. See, it is getting enabled. Okay, see, whenever if you perform any DML, any DRL, I require what? I require computation power. Computation power will be given by which guy? It is virtual warehouse. Got the point. Now, let me go here. Let me suspend it one more time. Understand the functional, simple thing. Simple if so same as like RAM, 8 GB RAM, like this, it's a functional. Okay, now let me create one more table. Tell me it's a what? Which layer come into picture? Which layer? The cloud service layer. Which layer again? The metadata management. So when we are performing any operation in this layer, we should require any power? We don't require any computation power. See, that's why I'm creating table. It doesn't require. Okay, require why? So here now we can able to cross verify. See here, warehouse size is there. Warehouse size is not nothing, but it doesn't require anything. But when I execute this statement, what happens? See, when I execute this statement, okay, now see here, three dots, view query profile. Now see, is there? Whenever it is not blank, so it is not blank, nothing but it doesn't require any computation power. So whenever it require nothing but it require computation power. This is the function. Now what happened? I'm trying to create one table. Which layer come into picture? The cloud service layer, the metadata management. Now what happened now?
What is metadata management here?
Like data about data, what type of columns, what data, number of records, all the information will be held by this guy. What's the data type? All the information will be held by this metadata. So data about our tables information. Okay. Now what happened now? I want to insert one more record. Nothing but it's a DML. Now tell me now what happened? Our data will be physically storing this layer with the help of this warehouse. Again, this information is holding by which guy? This guy. Okay, suppose see as of now, two records are there. Let me insert one more record. Now again, this information will be stored by again it's like data is capturing. Suppose see as of now, two records are there in EMP table. I am trying to insert one more record. Now physically our data will be stored three records. Again, this information is holding by which guy? This metadata is getting updated to three records. Okay, you need to understand is what? So whenever you perform any DDLs, that is nothing but creation of table, it doesn't require any compute because it's a metadata management operation. Now what happened now? I am trying to insert some record or I want to fetch some record. I require what? I require this guy. This require nothing but it's a computation, nothing but virtual warehouse. Our data will be stored where? In the storage layer in the form of micro partition. What is micro partition? Tell me. It's like small continuous unit of storage. You see, our data will be physically storing storing the storage layer in the form of micro partitions. Nothing but it's a continuous units of storage. Okay, storage. Okay. Now tell me, if I want to insert what I require computation power. Computation power nothing but say virtual warehouse. Now what happened? Again, this information is holding by which guy? In the cloud service layer, the metadata management. If I perform anything, what happened? Again, this data need to be updated by this. This is internally done by the Snowflake. I ask your question. This is important. If you're able to understand this concept, now we'll go for our cloning concept. Go ahead.
One question,
So-
Praveen.
Okay.
So the metadata also holds some data, right? So it
Like it's
doesn't
a
require any storage because it's about data about the data, right?
Not
So it
physical,
does-
so like information, metadata, like, okay, so like words, not actual. Suppose if you're simple use case, okay, you're staying, suppose like you're staying in Hyderabad, okay, physically you're staying in Hyderabad, but what happened, this information is holding by which guy? In the virtual, in the book, address book, your information with, but physically where? Physically here, it's like, it's information, like metadata, like not physical.
Okay.
So
Okay.
good, some other guy.
So
that
when
means
can we
storage layer tables data will store and table information like 3 records count
We'll
stores
get
in
from,
metadata.
we'll state in metadata, maximum value, minimum, those information will be getting like this. Metadata.
Yeah. Praveen, can we see the metadata for the table we created?
No, it's not possible.
We
Internally,
can
internally.
Sorry?
It is internally done by Snowflake.
Okay, we can't retrieve that data.
We can't retrieve the data. Okay, now see the same thing. Now what happened? Now let me come to the topic. Okay, now I am trying to create, so table, okay, so EMP, okay, ID, number. Now what happened? Now this is a metadata operation. Our data will be stored in this layer, the metadata information. But when I insert physically, what happened? Insert into EMP values. Now what happened? Now see, it's like physically we are storing in the storage layer. Does it require computation power? So now our data will be stored physically. This is the same thing. When you see this image, okay, tell me, you'll get some clarity, I guess. Okay. Now see this image. Okay. Okay. Now take the screenshot. Tell me how many layers are there totally? So 3 layers. Okay. EMP table. So see, our data will be stored in where? In the storage layer physically. Again, this information is holding by which guy? The metadata. Okay. Okay. So this is okay. Now what happened? Now I'm going for CTS concept. Nothing but what? I am trying to create a backup table. Now what happened? Backup nothing but what? Same thing we are trying to replicate. Now we're having the what? So storage cost. And if I want to insert what I require computation cost or not. Tell me the same data we are trying to replicate here. If I want to require what? I require computation power. Tell me now what cost will be there as of now. If I go for CTest, there will be storage cost and computation cost. One more time, if you're not able to understand. Now see how many records are there in my EMP table. Select star from EMP table. How many records? So 3 records are there. Let me make it to suspend. Okay. Now I try to perform CTest. So see syntax that what? So see create table EMP99S. Now what happened? Tell me now, does it require computation power or not? Does it require or not? Tell me. Any idea? Anyone? Yes. What about storage cost?
Yes.
Yes. Okay. See now, see here what happened. So how to confirm? See, go to query profile. Now tell me here, warehouse is there?
Yes.
Yes, nothing but what? If I want to perform CTest, I require computation power and storage cost. So you should, what's the conclusion? When I go for CTest, now what happened? I require storage cost plus compute cost. Okay. Same thing when I go for like, see what happened. Anybody tell me? When I go for like, Okay, syntax for like is what? Tell me what syntax for like.
Create table, table name.
So create
equal to
table.
table name.
Okay, see table name. Okay. Like.
Line.
Okay. And old table. Now tell me now, does it require computation power? Does it require storage cost? Tell me.
No storage
No.
cost.
No
No,
storage because no data, no
it is
storage
not
cost.
storing the
What
data.
about compute cost?
No computation cost as well.
Why? Why?
We are not using DRL, right? It's just we are using like, so that's why.
Not like this. So data, see, data is not getting. See, when I go for so we query profile, so it's like metadata operation. Now, see, doesn't require. So we are doing what? Okay, it's like it's a what? It's a metadata operation. See, like it's how simply we are trying to create the table, not the data. That's why it doesn't require computation cost. So see, what's the conclusion? No storage plus no compute cost. Okay, so this is so far good. Now, what about clone? So no, I'll explain the storage. How we can check? No, sir. What about computation cost will be there or not? Anyone? Any guess? See?
Will be there.
Yes, will be
It will be
there.
there.
Will be there. See. See what happened. Go to the query profile. Now see what happened. What is the thing? It's a blank. Nothing but what? No compute cost. I'll explain how it happens. See. So see for zero copy cloning, no storage cost and no compute cost. Now what happened? See this image. What exactly happening? Tell me. I'll explain in detail. What exactly happening?
Storing in the same location.
So see now what operation it say where exactly if I go here now what happened? What happened here? Tell me.
Both are pointing at the same location, storage location.
So both are so see 1 second. Give me 1 second.
Hello, sir.
Hello.
Yeah, he asked to wait for minutes.
Okay, see what happened. Tell me here. See 1 second. Okay, see what happened. Tell me. So we are getting physically storage and it said like this. But when I hear what happened, what operation say? So we see we are taking only the metadata information. So tell me, metadata information require computation power or not? Say metadata operation, tell me.
No.
No.
No. Okay, see what we discuss in this normal table creation. So we are creating our data physically. If not physically, this is like metadata operation. So point you need to remember is that what? Let me go to the paint. Understand this simple concept? Okay, see. Let me take the normal table. Okay, so this is my normal table. Contains what? Assume like there are 100 records are there and 100 MB storage is there. Now what happened? Now I'm trying to take a backup. Backup nothing but what? Okay, see same table, Control C, Control V. It's a what? It's an okay. Again, our data will be storing physically. Now I require computation power. So this is normal C test. But when I go for okay, see when I go for cloning concept, so see this is our data, physical data. It contains 100 records. Now what exactly now I'm trying to take one more copy, one more copy, one more copy. But what happened? All the three things are pointing to same storage, same storage. Now what exactly we are copying here? We're copying only the metadata information. See, metadata information of micro partitions, not the actual data. Here, what exactly we are copying this thing? The metadata information of micro partitions about data, not the physical data. But here, physically, we are trying to copy. That's why I require storage cost and the computation cost. But here, what exactly I'm trying to copy? Copy only the meta. See, what exactly I'm trying to copy? Copy only the metadata information, not the actual data. That's why it doesn't require. It's a metadata operation. It copies only what metadata information of micro partition, not the actual data, and it's a metadata operation. It doesn't require any computation cost. Since we are not storing physically, no storage cost. Okay, no computation cost and no storage, because we are just referring the same thing, not like actual data. See what happened here. Once we go here, we are again replicating one more time the same data. It is the function. That's why no computation cost and no storage cost for zero copy cloning. Ask a question.
Yeah,
So
I have a
copying the
question.
Okay.
Oh, please go ahead. Please go ahead.
Okay. You mean like copying the table in the form of micro partitions in cloning?
No, not exactly. We are not copying. No, we are copying only this information. So see, this only this information is copying. That's it. Only the main. See, okay. See here what happened. So this is my main table. Okay. So this is my main table. So when I copy, when I take a clone copy, what happened? So we are not copying the data. We are copying only it's like nothing but what this table contains 10 records. This 10 records is storing in 3 partition. Those 3 partition information only we are trying to copy. This was. But so these two images, when you see these two images, we'll get some clarity. Okay, see here what happened. So our data physically we are trying to replicate one more time. So there'll be storage cost. Once we replicate, we'll require computation cost. But here only single storage, so we can take n number of copies. But what happened? We are copying on the metadata information, not the actual data.
Okay.
Got it? I'm good.
Since it is pointing to the old storage layer, like what if it is deleted?
I will see that
then-
same. We'll see the same.
Oh,
The delete
okay.
modify, we'll see the same. So
Okay.
as of now, what? Okay, see now we are taking this table. If any changes, what I will see the same thing changes. Okay, as of now, you understand what? So it's a metadata operation. Metadata operation doesn't require any computation cost and any storage cost. This is clear. So tell me, suppose I'm having 1 GB table is there. Okay, 1 GB table and it having 1 million records is there. Now I want to take a backup table. Out of these three things, which you prefer and why?
Clone. Because we
Because
don't require storage and compute.
no computation cost. Remember what happened ultimately as a part of Snowflake developer, we should reduce the storage cost and the computation cost. If I go for CTAS, what happened? I have storage cost and the computation cost. And every month, what happens? Snowflake will be billing the storage and the computation cost. To avoid the storage optimization and cost optimization, what we can go for cloning. That's what the functionality. So cloning is nothing but it is used to take a backup, okay, backup of a table or a snapshot of a table or replication of a table without any additional storage and additional cost. So it's like a metadata operation, not the physical data we are copying. We are copying the metadata information of micropartition, not the actual micropartition we are copying. Only the metadata information we are trying to copy. This is the concept of cloning. Go ahead. Okay, so this is the
So when we
concept.
refer clone, when we refer clone, it is zero copy cloning only in in Snowflake.
Zero
No other
copy
cloning is
cloning.
possible.
Okay, so zero copy cloning, nothing but no storage and no that's what it's called as zero copy cloning, no storage cost. Okay, so this is so far good. Okay, now what happened? Let me come to the questions. Your questions will be answered here. Only see now what happened. Tell me what is cloning? Cloning is nothing but it's nothing but taking a backup or replication or snapshot of a table. Tell me the same thing. We can clone table, we can clone schema, we can clone database. Tell me the syntax for table as table syntax. So create table, table name. Okay, so clone old table. Same thing if I want to get schema, what I should take? Create schema. Schema name, old schema. Same thing if I want to take the database, instead of schema, we put database. Okay, see DB name. So DB name and old DB. This is so far good. Okay, so this entire database we can able to get without any store, and it's also called as fast cloning. Tell me why it's called as fast cloning, because we are not copying actual data. That's why it's a fast kind of thing. Okay, fast cloning. Okay. Next one is that why cloning is called as zero copy cloning? Tell me.
Because we don't require any storage and no compute cost.
No storage and no computation cost. Tell me in which situation you have used clone your project. Tell me what's the use case of your project, and tell me.
In case of we need a
When there is
duplicate.
a lot of data.
And tell me what is the scenario? Okay, why will go for cloning?
For testing purpose.
It's testing purpose. Now suppose like see what happened. I am having one prod database. Simple thing. Suppose see. So in my prod database, it contains 100 tables are there. 100 tables occupying 100 GB storage. Now what happened? One issue occurred. Okay, now so the team leader asked to find the RCA. What is RCA? It's a root cause analysis. Now I want to find what is the exact issue it is causing. Tell me the prod database. Can you debug the code?
No.
Tell me. No. So what happened? We want to bring all this data to local machine, local lower environment. Simply what? Simply use create database. Okay, see. So prod DB backup. Okay, clone prod DB. Now what happened? So now we are replicating all the tables without any additional storage. We can able to perform our testing operation, and we can find the RCA kind of thing. Okay, so mainly for what? Mainly for testing purpose, or mainly for backup purpose. Okay, if you want to store for reference, we'll go for testing, or backup, or we'll go for cloning concept. In my project, for testing purpose or for cloning, we can able to make it work. Okay. So next one is that what? So does a cloned object will have storage?
No.
No. Okay, say cloned object will have storage. Now, okay. Now tell me now point you need to understand is that what? Okay, now how can you prove? So theory wise is okay. So how can you prove?
Warehouse, by looking at the warehouse
Query
status.
No,
details.
Warehouse nothing but it's a computation cost. Now I'm asking. So see, does
By
cloned
looking
object
at
will
the
have
storage layer.
storage layer. How can you check? Tell me, can you check physically? Yeah? No.
We have to
I will
compute
check.
the,
Tell
yeah,
me.
by query, through query, we have to calculate the storage of a cloned table.
Okay, see now what happened. See, so for this purpose now we're having one information schema as this. Okay, see, so see there is a view. Okay, by this view we can able to say it's a storage is there or not. Okay, see, what's the view? Tell me how to find list of tables. List of tables.
So
Show
you'll have to
tables.
start from
Instead of show tables, information schema dot tables. Okay, so this is one view. Same thing. How to get list of columns? Information schema dot list of columns. Same thing. One more important, that is information schema dot so table storage matrix. So by this view we can say what exactly the storage is there. So information schema dot table storage matrix. Tell me. So I want to get list. Tell me how to see list of tables. Show tables.
tables.
Okay. Starting with EMP 99. How to get only EMP 99? Tell me.
Like
Tell me.
Pattern matching, like
Pattern matching. Okay, so what the table created just now? 1 second. EMP, yeah? EMPT. Okay. EMPT. So see, show tables like EMP. So EMP percentage. Our table is EMP. Yeah, okay. EMP underscore T percentage. You should get 4 tables. Okay, see, 4 tables came on. So 4 tables. Okay. Now see, let me help you the same thing. This is important. Listen. Now see, this is so far good. Now same thing what happened, same. So information schema dot table storage matrix. Okay, where? So table name like, okay, EMP underscore T percentage. Okay, see. Now how many tables came? So there are so many tables here. But I want to get, see, there are multiple databases are there, but I want to get my own database. Tell me how to get this database. And here catalog nothing but a database. Under table catalog, how to get this current database? Go for current database. So database. Now so you'll get only our database will be populated. Totally how many tables? So 4 tables. Let me take the screenshot. Now you should say what happening here. So there are totally how many tables? 4 tables are there. So by seeing this one, tell me which is the main table, which is the clone table. Anyone, any guess, any idea?
table name.
EMT underscore T.
How?
EMP underscore.
How you're saying it's a main table?
Because light clone and CTAS are used for backup.
Suppose if I put EMP1, EMP2, EMP3, EMP4, I don't know anything. Then see, you see next columns.
Clone.
Clone group ID.
See what happened. How we can see? Tell me both are same. Tell me both are same. Okay, tell me both are same. What about clone? Same or different? ID? Different. So see, you need to say what? When both ID, clone group ID, both are same, it's not made, it's a main table or base table. But here what happened? This is different. Tell me this is pointing to where? 73730, where from it is getting from?
Original table.
From the original table. Okay, see. So when the ID, clone group ID, both are same, it's a base table. When both are different, nothing but what? It's a what? It's a cloned table. So this is cloned from where? From the main table. Main table. Okay. Now see the same thing. Let me go for one more image. I'll come here. 1 second. I'll explain 1 second. Hold on. So here, see the same thing. Tell me out of these 4 tables, which is main table? Tell me. 16388. Okay. So 14391. So these 3 are main tables. What about clone table? It is pointed to this a cloned object. Now what happened? Tell me now why it's 0? Storage cost?
Storage.
No storage.
No storage.
No storage. Okay. So it's a why sit as? Because physically storage. Why 0 here? Like because no records are there. Okay. See now point is now see, how can you confirm by using what? Information schema dot table storage matrix. Active bytes will be 0 0. Okay. How can you say like what happened? So Snowflake 0 copy clone doesn't occupy 0 storage. How can you prove? By using what? By saying active bytes will be 0 0. Got the point? So you should say, so see information schema by using information schema dot table storage matrix, active bytes will be 0. Then we can say it's a 0 copy cloning. Clear? So far. Now, but what happened? Let me go here and let's see this image. Tell me in the EMP table data records are there or not? Yes or no? Records are there or not? Tell me in EMP table.
No records.
No records. Records there, no? 2 records are there. Records are there. So 2 records are there. Okay. But what happened? Showing 0. Anybody knows the reason? But showing 0 for all the things. Anyone?
Because immediately it's not updated.
So see, remember now, see here what happened. So correct. See here, there is a latency. Latency nothing but some delay. Okay. So Snowflake mentioned the documentation saying that. So there is some data latency. Latency nothing but what takes some time to update these records in this table. Okay. Tell me. So it's like around 1.5 hours to 2 hours latency. Okay. After 2 hours, tell me the data will be populated where, tell me, where? After 2 hours, the data will be populated where? That's fine.
Theta's
Where?
clone.
Clone,
No, base table and
base table.
Theta's table.
So base table, and if I go for clone, there is no concept of discussing. Tell me, EMPT, then what is the thing? Like will be there? Huh?
No data.
What about clone?
No data.
Clone? No.
No.
Only CTAS and main table. So clone why discuss? Because a metadata operation doesn't require any storage and computation cost. Okay. How can you prove? We need to wait for 2 hours and we should check it working. This is the concept of zero copy cloning. So without any additional storage, we can take the backup. Okay. Now next thing is that what next question? See the next question. So does cloned object will have storage? Answer is no. How can you prove? Information schema dot table storage matrix. The active bytes will be 0 after 2 hours. Okay. Tell me, when you make any change to cloned object, does it get referred to the base table or not? Tell me, suppose let me have one more table. Okay.
Yes, because they point to the same storage.
No. See what happened. See how many records are there here? 2 records are there. Okay. How to take a backup? By saying clone. Why? Because no storage. Okay. See. So EMP00 clone from where? EMP. Okay. So EMP. So EMPT CL output and clone the same thing. Okay. Now here you need to tell me both will have, as of now, both will point to the same storage and the same data. Both will have two records are available. Okay. Now what the question, their expectation is that what? Okay. See. So when you make any change the cloned object, okay, let me insert one record in my cloned table. Okay. So values. So 1, 1, 1. Okay. Now tell me now what happened. How many records is there? As of now, 3 records will there. Now, what about the cloned main table? 2 or 3? Anyone any guess? Any guess?
2.
2
only.
Why 2?
Because we have not
We have cloned with only 2 records.
Okay, see now, see, you should say what happened. So whenever we make any change to the cloned object, does it get reflected or vice versa? Because we should say like both are independent to each other. When you make any changes, the changes won't be reflected to other thing. That's the concept. So both are independent. You should say like both are independent objects. Whenever I make any changes, these changes won't be reflected. See, to this thing. Okay. So whenever I make changes, these changes won't be reflected because both are independent to each other. Got the point? Same thing. What's the view? Information schema table storage matrix. Now question is that no, a new record inside the clone table, does it have storage or not? Tell me.
It will have storage.
Storage. Yes. Where exactly it store? In the new micro partition. See what happened. Whenever I insert any record in the main table or clone table, there'll be new okay, information will be stored in new micro partition. Nothing but again storage cache will be there. Whenever if you do any changes, what happened? It will separate storage will be there. Then it have storage cache will be available. So point you need to remember, whenever perform now, both will have independent to each other. See the question, you can ask the question on a second. Now see, can you perform DML operations in the clone tables? Huh?
Yes, we can.
Yes, we can. Okay, say how will it impact original tables?
No
impact. No, because both are
independent.
Independent. You should say like both are independent to each other. Same thing. So, see the same questions we can ask. Hold on. So see, tell me, does cloning occupy storage? Huh?
No.
No. How can you prove?
No.
Information schema dot
Through information
schema
dot table storage matrix view. It's a view. Okay, we need to wait after 2 hours. After 2 hours, what happened? The active bytes will be 0, 0. Tell me, does cloning uses warehouse? What's warehouse?
No.
How can you prove? If you execute now, what happened? If you execute and go to the query history, we can go to the query history. So see, create table. Tell me, does it require or not? See, no warehouse. No. Okay. See, by using warehouse, we can able to check it down. Okay. Now, see, next one is that what can we clone the clone table again? Huh?
Yes.
Suppose see what happened. Yes, now we see what happened. So this is my table, cloned table. Again, I want to clone table from by using clone table. I want to clone one more time. Tell me it's possible. Yes or no? Okay, it's possible. Yes. Okay, same thing. Again, I want to clone one more time the clone table. Okay, it's possible or not? It is possible. But tell me, all the cloned objects will be pointing to what?
Base table.
Original storage.
Okay, see what?
Base table.
Which one base table? See what happened. See, if you see EMP, TT, okay, current database. Now see, EMPT, EMPTT, CL. All these things will be pointing to what? Pointing to what? 73730. That is main table. You can take n number of clones, but all things will be pointing to the main
Base
table, the
table.
base table only. This is the functionality. Okay, got the point. Is the zero copy cloning. Ask a question. Go ahead.
So related to storage, I have a question.
Go ahead.
When